Hey guys, welcome to question MM250 of the Maths Methods Fortify study guide. Now if you've made it this far, you're up to the last question in the differentiation section, and I commend you. You've made it this far and that's awesome. So thanks for sticking along with us, and let's jump straight into this question. So the graph of f from negative a to b is equal to 1 on 10 x plus a, x take a, x take b, as shown below, where a and b are positive constants. Awesome. So the gradient of f of x at point negative 2, 0 is 14, 5. Show that a equals 2 and b equals 5. Fantastic. So this question is saying that the gradient of f of x at point negative 2, 0 is 14 on 5. Immediately tells us that this point here is negative 2, 0, right? Because this is a cubic, this is the only point that it's actually going to pass through our x-intercept apart from these two. So we know that this point actually has to be negative 2, 0, right? If negative a is equal to negative 2, then that means, so negative a equals negative 2, therefore a equals 2. That's our first mark. So that's showing that a is equal to 2. That's pretty much all the work you need to do. And then from there we can actually say that f of x is equal to 1 on 10 outside of x plus 2, x take 2, x take b. And we know that the gradient at x equals negative 2 is 14 on 5. That's what the question tells us. So f of x, if we expanded this out, we would get x cubed on 10 minus bx squared on 10 minus 2x on 5 plus 2b on 5. We know that f dash of negative 2 is equal to 14 on 5. So our gradient at negative 2. F dash of x is equal to 3x squared on 10 minus 2bx on 10 minus 2 on 5. So therefore, our gradient, 14 on 5, is equal to this with negative 2 in for x's. So 3, negative 2 squared on 10 minus 2b, negative 2 on 10 minus 2 on 5. And then from there, let's just go back up here. From there we get 14 on 5 is equal to 6 on 5 plus 2b on 5, take 2 on 5. And then from there we can say that b is equal to 5. If we kept going with this, we would get that. So that's our second mark. So we've proven that a is equal to 2 and b is equal to 5. So let's move on to part b. Part b asks us to find the coordinates of p and q, which I didn't actually put on here before, but that's q. The stationary points of the graph of y equals f of x. Awesome. So from our previous question, we know that f dash of x is equal to 3x squared over 10 take x, take 2 on 5, right? Based on the fact that a is equal to 2 and b is equal to 5. So this is what we end up getting. At our stationary points, we know that this is equal to 0, right? So 0 equals 3x squared on 10 take x, take 2 on 5. Now from here, we would solve for x in CAS. We have our CAS available, so we might as well use it. So in that case, x is equal to 5 take root 37 over 3, and x is equal to 5 plus root 37 over 3. This is our first mark, right? So we've got our x values, but we don't have our y values, right? Because we're looking for coordinates, so we're going to need to sub these in. So from here, we can say that f of, and the reason we're doing this is because the question didn't ask us for decimal places. It didn't ask us for anything, which means that we need to give exact values. So f of 5 take root 37 over 3 is equal to 55 plus 37 root 37 over 135. And f of 5 plus root 37 over 3 is equal to 55 minus 37 root 37 over 135. And then from there, we can simply state our p and q coordinates. So p is our lower, whoops, didn't mean to rub that out, 55 plus 37 root 37 over 135. Awesome. So p is our lower x value, because it's down here, which means that p is equal to 5 take root 37 over 3, 55 plus 37 root 37 over 135, and q is equal to 5 plus root 37 over 3. 55 minus 37 root 37 over 135. Now I know this seems excessive, but the question didn't ask us for decimal places, so we need to give it in exact form. So there are coordinates of P and Q, and that gives us our final answer for part B, which was 2 marks. Awesome. Let's move on to part C. Part C asks us for the average rate of change between points P and Q. So guys, as always, average rate of change means gradient. Okay, so we're looking for the gradient between P and Q. So if you can imagine a line between P and Q, we're looking for the gradient of that line. So we get y2 minus y1 over x2 minus x1, which means we're going to be using these this stuff here. I'm going to give myself a lot of room here. So our second, well, it doesn't matter what y value goes first, but I'm going to call Q our y2. So we get 55 minus 37. Actually, you know what? I'm going to say P is our other y value. So we get 55 plus 37 root 37 over 135 minus 55 take 37 root 37 over 135 over x2 minus x1. So 5 take root 37 over 3 minus 5 plus root 37 over 3. Cool. Now from here, we simply just keep evaluating this. So that's actually our first mark, is this bit here. So just plugging in our values to our gradient formula gives us our first mark. From here, we can say that our gradient is equal to negative 74 root 37 over 135 over 2 root 37 over 3, which gives us negative 222 root 37 over 270 root 37. The root 37s can cancel out, and that simplifies to negative 37 over 45, which is our average rate of change. So I use ROC as rate of change. It just makes intuitive sense to do that. So that's our second mark for part C, and our final answer. So let's move on to part D. Part D is a 2-mark question. And it says the line PQ is perpendicular to the tangent to the graph of y equals f of x at x equals k. Find all possible values of k correct to 3 decimal places. Awesome. So what we're saying is this line PQ is perpendicular to the graph at certain spots. Okay. So what we're going to need to do is find out the points where that is. Okay. So if it's perpendicular to the points, that means that the gradient of PQ is the negative reciprocal of the tangent. Okay, so negative 1 over gradient of the tangent, which means that the gradient of the tangent is going to be equal to negative 1 over negative 37 over 45, which gives us 45 over 37. Okay, so that tells us that the gradient of the tangent is going to be 45 on 37, and because we know that our gradient function, f dash of x, is equal to 3x squared over 10 minus x minus 2 on 5, that means that this gives us our gradient of this function at any point. We know that the gradient is going to be 45 on 37, which means we can say 45 on 37 is equal to 2x squared over 10 minus x take 2 on 5. Now this is our first mark, okay? Subbing in our value for f dash of x is this, and we know that we're looking for the values of x equals k, okay? So at these points where this gradient occurs, x is equal to k. So that means 45 on 37 equals 2k squared over 10 minus k take 2 on 5. Awesome. Now, from here we can simply solve. So we have our CAS available, so why not use it? I would solve in CAS here. So solve in CAS. K is equal to negative 1.191 and k is equal to 4.524. Now that's the 3 decimal places, which is what the question asked for, which means that's our second and final mark for part D. So let's move on to part E. Part E tells us that we have a triangle OMN inscribed within the function f of x. So we've got this new triangle in here. This is M, which is M f of M, and this point here is N. Awesome, we've got this shaded area here. Sweet, so let's get rid of this. Now part EI is 1 mark. And what it says is show that the area of triangle OMN is given by this formula here. Awesome. So, first things first is that because it's a triangle, we know that the area is going to be equal to 1/2 times base times height. Now, our base of this is M, right? Times M. And our height is going to be F of M, okay? So times F of M. Now, F of M is just this with all of our values of X subbed in as M, which means that we get 1 on 2 times M times 1 on 10 M plus A. Well, actually we know that A is 2, so M plus 2, M minus 2, M minus 5. Awesome, which gives us M over 20 times M plus 2, M take 2, M take 5. Which actually gives us M on 20, M cubed, take 5M squared, take 4M plus 20, which is our answer. And that's it. So that's our first and final mark for part EI. Let's move on to part EII. So part EII is a three mark question, yep. Sweet. And it says, find the value of M such that the area of the triangle OMN is at its maximum and state this maximum area correct to 2 decimal places. Sweet. So we know that if our area is at a maximum, then the derivative of the area function is equal to 0, right? So dA dm, which is the derivative of this, is equal to 0. Therefore, 0 equals this derivative, which is going to be M cubed over 5 minus 5M squared, take 4M plus 20. Whoops, I started looking at something else then. M cubed on 5, take 3M squared over 4, take 2M on 5 plus 1. Sweet. So that's going to be our derivative function. And because we recognize that this is equal to 0 at a stationary point, that's our first mark. Solving this in our CAS, so I would say CAS M is equal to negative 1.22, M is equal to 1.04, and M is equal to 3.94. But we have a restriction on this, right? Because our x-intercept here is 2, and the triangle is between 0 and 2, right? So our triangle has to be between, or M value has to be between 0 and 2, which means that M equals 1.04. That's our second mark, recognizing that and taking this from our possible values. From there, we know that that's our M value, but we still need to find our maximum area. So we know that our area is given by M on 20, M cubed, take 5M squared, take 4M plus 20. We know that M is equal to 1.04, so we can sub that in. 1.04 over 20, outside of 1.04 cubed, take 5, 1.04 squared, take 4, 1.04 plus 20, and that gives us 0.60 units squared. That's correct to 2 decimal places. We have our units there, units squared. That's our third and final mark for question 250. If you have any questions, as always, guys, please hit me up in the comments below. But again, if you've made it this far to 250 questions, congratulations. Thanks for sticking with us. And yeah, let me know if you have any questions. Until next time, have a great one.